Greetings to everyone. Welcome to Dharma Foundation. In this video, I am going to give you full concepts of complex numbers. I hope it will help you in your preparation. Before starting, I would like to request you to please subscribe and share my YouTube channel so that it will reach to the poorest of the poor. Thank you. Complex numbers. If any number in the form of a plus ib is called complex number. So, and we denote complex number with Z. With Z, here I represents iota and this equals to under root minus 1. Again, A comma B should belongs to R. So this is the condition to form a complex number. So how we can write this complex number? This Z equals to A plus IB. Here A is real number and B we call as imaginary number. So now let's come to the properties of iota. Properties of I. Now, as I said you, I is equals to under root minus 1. Now, I am squaring this I. What we will get? Under root minus 1 whole square. So this will become minus 1. I am cubing I cube. Cubing this iota, then it will become I cube is equals to I square into I. What is the value of I square? I square is minus 1 into I. So this equals to minus I. Now, I to the power 4. I to the power 4 is equals to I square into I square. The value of I square is minus 1. Again, this I square value is minus 1. So, minus 1 into minus 1, it will become 1. Again, now, I power 5 is equals to I power 4 into I. This is like we can write, right? So, this I power 4 value is 1. So, this equals to 1 into I is equals to I. Now, so how we can represent this iota? That means, let's say, I power 4k plus n is equals to I power 4k into I power n. I am using this formula I power n. Here I am using the formula of A power m plus n is equals to A power m into A power n. So this formula I am using here. As we know that for I power, we can write this as I power k power 4, or else we can write this I power 4k in I power 4 power k into I power n. And we know that I power 4, value of I power 4 is equals to 1, right? So I am substituting 1 here. 1 power k, whatever the power of 1, the value we get is 1 only. So into I power n. So this will become I power n. So if the power of I in the form of 4k plus n, then we can directly conclude that I to the power of 4k plus n equals to I to the power of n. So this is the property of iota. Now, will 0 form a complex number? 0, you can say 0 as a complex number? Yeah, because how we can write 0 into the complex form? Let z is equals to 0 plus I into 0. This is how we can write 0 in the complex form, right? So, here this 0 is real part and this 0 is imaginary part. Now, let's compare two complex numbers. If two complex numbers are given, let Z1 and Z2 are two complex numbers. If Z1 is equals to Z2, that means Z1 means this, I am taking Z1, let's take Z1 is equals to X plus IY. Z2 is equals to A plus IB. That means X plus IY is equals to A plus IB. Here, what we will get is real parts in these two complex numbers. These real parts will be equal and these two imaginary parts will be equal. That means real part X is equals to A and Y is equals to B. So this is the property of. Now let's come to the conjugate form of complex number. Conjugate form of complex number. I am writing directly Cn and here I am complex number representing this as Cn. So if we know the complex number, this Z is equals to this X plus IY. This is the complex form. Conjugate form. How we can write conjugate form? We represent this as Z bar in this form. So this will become this X plus IY whole bar. So this equals to X minus IY. So this is the conjugate form of complex number. Now let's see the properties. Properties of conjugate forms. There are certain properties for conjugate form of complex numbers. We know that Z is equals to X plus IY. So what I am doing here is I am adding complex form plus conjugate forms. This means Z is what? X plus IY plus Z bar is X minus IY. So this equals to this IY, this will get cancelled. You will get what? 2x. Here x is what? Real number. That means 2 into real number. If you add this complex number and conjugate form of complex numbers, you will get 2 into real number. Now let's subtract this conjugate form of complex number from conjugate complex form. That means Z minus Z bar. This equals to X plus IY minus X minus IY. So this will become X plus IY minus X plus IY. This minus into minus, it will become plus. So here this x will get cancelled. What you will get? I into 2y. That means this 2y, IY is what? Imaginary form, right? So that means 2 into imaginary number. So this is how we can subtract complex conjugate form of complex number from complex number. One more property is, let z is equals to x plus iy, right? Now z bar is equals to x minus iy. Now z double bar, I'm doing conjugate form of x minus iy. What it will become? X plus iy. So this is what, this is z, right? So that means z double bar is equals to z. And this z plus z bar, this whole bar is equals to z bar plus z. Again z minus z bar, this whole bar is equals to z bar minus z. So these are the few conjugate properties of complex number. And z into z bar is equals to 2 into real part of complex number whole square plus 2 into imaginary part of complex number whole square. So this is one more property of complex form and conjugate form. If you multiply complex number with conjugate number, so we will get 2 into real part of z complex number whole square plus 2 into imaginary part of complex number whole square. Before going further, let's come to the modulus of complex number. So we can represent modulus of complex number in the form of mod z. So this will become mod of x plus iy. So this will equals to under root x square plus y square. So this is the formula for modulus of complex number. Here x is what? X is real number, right? And y is imaginary number. So how we can write this? Under root real part of complex number whole square plus imaginary part of complex number whole square. So let's take one example. Let z is equals to 3 plus i4. Then what will be the conjugate form of this complex number? Z bar is equals to 3 minus i4. Again, what will be the modulus of this complex number? Under root real part square 3 square plus imaginary part square 4 square. This will become 9 plus 4 square is 16 is equals to under root 25 is equals to 5. So this is how we can solve this complex number questions. If you know the formula of modulus and conjugate. Now let's see the properties of modulus of this complex number. Properties of modulus complex number. If first one property is, if modulus of z is equals to 0, that means what? This real part will become, real part of complex number will become 0 and imaginary part of complex number is also become 0, right? That means mod z is equals to under root x square plus y square, right? So if you substitute 0 in x square and y square 0, that will become 0, modulus of z equals to 0. And second property is mod z is equals to mod z bar, again mod of minus z. So how we can prove this? Let's take z is equals to x plus iy, right? Now mod z is equals to under root x square plus y square. Again z bar will be x minus iy. Now mod of z bar will be under root x square plus minus y whole square. So it will become under root x square plus y square. Again, now mod of minus z. Mod of minus z will be, let's take first minus z, it will become minus x minus iy. So now mod of minus z will be under root minus x whole square plus minus y whole square. So this will become minus x under root minus x whole square will be x square plus minus y whole square will be y square. So from this we can conclude that mod z is equals to mod of z bar and mod of minus z. So all these three values are equal, right? So third property is mod of z into z bar is equals to mod z into mod z bar. So this is one more property. Let's go to the fourth property. Mod of z1 plus z2 whole square is equals to mod z1 whole square plus mod z2 whole square plus 2 into real part of z1 into z2. Another property is mod of z1 minus z2 whole square is equals to mod z1 whole square plus mod z2 whole square minus 2 real part of z1 into z2. Let's come to the other property. Mod z1 plus z2 whole square plus mod z1 minus z2 whole square is equals to 2 into z1 square mod z1 square plus mod z2 square. So these are the few properties of modulus of complex numbers. Now let's come to the square root of complex number. There are two conditions to find the square root of complex number. One is if imaginary part is greater than 0, then square root will be square root of z is equals to under root mod z plus real part of z by 2 plus I into mod z minus real part of z by 2. Again, if imaginary part is less than 0, less than 0, then mod z will, then under square root of this complex number will be, then under root z is equals to under root mod z plus real part of z by 2 minus I into mod z minus real part of z by 2. So let's solve one question based on this formulas. Let z is equals to 3 plus I4. Here, if you observe the imaginary part, it is greater than 0. So, then we will use this first formula to find the square root of complex number. Then, square root of z will be under root. Here, mod z is how much? This mod z is equals to under root 3 square plus 4 square. So, this will become under root 25. This is equals to 5. So, that means mod z value is 5 plus real part is how much? Real part is 4 by 2. Again, plus I into, what will be the imaginary part? Under root mod z is 5 plus minus real part of z is 4 by 2. So, what will this become? Under root 9 by 2 plus I into 5 minus 4 is 1. So, 1 under root I into 1 by 2. So, this is the square root of this complex number. Let's solve one more type. If this z is equals to minus 3 minus I4. So, here if you observe the imaginary part, here imaginary part of z is less than 0. So, then we use the second formula to find the square root. This mod z will, under root z will be under root, here mod z value is 5 plus real part is minus 3 by 2 minus I into under root 5, mod z value is 5 minus real part of z is minus 3 by 2. So, this will become 5 minus 3 is 2, 2 by 2 is 1. Again minus I into 5 minus 3 into minus 3 plus 3. So, 5 plus 3 is 8. 8 by 2 is 4. So, under root 4 value is 2. So, solve this square root of z. So, if you know the imaginary part is greater than 0 or less than 0, by knowing that we will substitute the given formulas according to the question.